All right, let's pick it up from where we left off yesterday. We were doing some log equations. So we're going to apply it to real life scenarios. Ever heard of pH
Mm-hmm.
in chemistry? What's the pH of water? So pH goes from, usually it goes from 1 to 14.
So water is 7.
So pure water is 7. Pure water, but our tap water is not going to be 7. It has some fluoride and some minerals in it. It's going to be a little bit on the alkaline side.
Mm-hmm.
What's the pH of the ocean? What do you think it is? There's lots of water in the ocean. There's also lots of salt. Is it going to be more acidic or basic? Think about it. Would
More
acidic,
basic.
yeah, it's going to be more basic. It's fish and stuff. Aquatic life, it's an acidic environment is not the best for them, so it's more basic. pH of the ocean right now is about 8.1. So it's quite alkaline. Ever heard of ocean acidification?
Mm-hmm.
What's the idea behind this? It's because where our carbon dioxide that we release, yeah, from a bunch of different things, from fossil fuels and whatnot, when it goes up into the atmosphere, it's gonna react with water, and that's gonna produce carbonic acid. And when it rains, the carbonic acid in the atmosphere, it's gonna pull it down into the ocean. Well, actually, it's gonna pull it down everywhere, but most of the water is gonna flow back into the ocean from the rivers and such, which means that the ocean's getting more acidic. Like 100 years ago, the pH of the ocean was 8.2. Right now, it's 8.1. 100 years later, I don't know. Probably will be more acidic because we're not doing a whole lot to combat carbon emissions. Anyways, that's the idea of pH. Now let's see how it's actually calculated. It's just a number, but how do you get those numbers? Here's some examples of pH. It usually goes from 1 to 14, but it doesn't have to. It can go from negative infinity to positive infinity, but that's very, very unlikely. It would mean it's like impossible to work with. Um, Tomato juice is a little bit acidic, right? Caffeine, pop, soda cans, whatnot. Lemon juice is pretty acidic too. And then we have our acids, hydrochloric acid, hydrofluoric acid. On the other side, in terms of the bases, we have soaps and bleaches and drain cleaners. Let's see how we actually calculate them. All of it, pH, has to do with the concentration of the hydrogen ion. This is what makes things acidic or basic. The square bracket here, as you can see here, the square bracket represents concentration. This means the concentration. And then we have the hydrogen ion in there. How do you get hydrogen ion? Well, when something dissociates, let's say you have water, right?
Mm-hmm.
You'll get something like this. This is the ion decomposition. And almost anything can do this. Like if you have our carbonic acid that we saw before, would be something like this. You'll do this in chemistry later, but this is the idea. When something decomposes, goes through decomposition, it's gonna give hydrogen ions. This is one definition of an acid. There's more definitions. It doesn't have to be H per se, but for us, let's stick with the H's. Let's answer this question. The formula for pH is negative log of the hydrogen ion concentration. Part A, it says find the pH if the concentration of the hydrogen ion is 0.0001. In this, which variable is this number?
H.
Yeah, it's gonna be H plus. So for A, you just do pH is negative log of 0.0001. Negative log of 0.0001, and that gives us 4. So it's pretty acidic, right? Like on our chart, 4 was like tomato juice. That's part A. Part B, the pH of lemon juice is 2. Calculate the hydrogen ion concentration. Which variable is 2 here? It's the same equation.
The pH.
The pH. So pH is 2. Let's find the hydrogen ion concentration. So this is our unknown. How do you solve this equation for H plus? Remember, there's an invisible base in there somewhere. And this has something to do with going from one form to another.
Ten to the power of 2.
Yeah, that works. Usually you want to get rid of the minus sign.
Mm-hmm.
So let's get rid of that. Multiply both sides by -1. You get -2 is equals to log of H plus. And then you do 10 to the power of -2 is H plus, the concentration. What is that? That's like 1 over 100. That's like 0.01 moles per liter. And that's the answer to part B, okay?
Mm-hmm.
This thing looks weird. This is a unit of concentration, moles per liter. What does it actually mean? Liter means a liter, right? Let's say you have a beaker or something, a vessel, you have a liter of items in here. Mole is a weird unit in chemistry. It has to do with the mass, okay? So the higher the mole, the higher the mass. Here's the formula for mole. Why not? I'll give it to you. Mole is denoted by N. That is equals to the mass of the substance divided, the mass of the substance that you have divided by its molar mass. If you look at a periodic table, have you ever seen a periodic table?
Mm-hmm.
You'll their molar masses will be given, right, in a periodic table. You see here, like for chromium, it's like 51.996. So that's the molar mass. It's a constant, right? Let's say, what's an easy one? Let's say we have hydrochloric acid. Let's say this is a solid, comes in like a powder form. Let's say you have a little thing and you have powder. This is powder. Let's say you use like a spoon to pull out 2 grams of this substance. The question is, what is the mole? How many moles is 2 grams? And the way you do this is that, well, you pulled out 2 grams, so the mass that you have is 2. What's the molar mass of hydrochloric acid? So what's the molar mass of H and what's the molar mass of Cl? Go to this chart. Hydrogen is 1. It says right up there 1. And then the molar mass of chlorine is what? Chlorine is here. What's the molar mass of chlorine? It's this number up here. It's like 35. Let's say it's 35. So hydrogen is 1. This is 35. So you get 2 over 36. So it's like 0.05 moles, okay?
Mm-hmm.
Then you put this in a liter of water. Therefore, the concentration that you had 2 grams of hydrochloric acid, powder form. You put that in 1 liter of water. The concentration of this acid now becomes 0.05 moles per liter. That's the idea. It's a little bit of chemistry. You'll do this in more depth, I'm sure, in grade 11. Anyways, back to this question, part C. So they're saying if the hydrogen ion concentration is the measure of the strength of an acid, how much stronger is an acid with pH of 1.6? So they're giving us two different pH. One of them is 1.6. The other one is 2.5. Which one do you think is stronger? Stronger means more acidic.
1.6.
1.6. It's asking us how much stronger is it? So now what do we do? So when it says how much stronger, they're asking you for the ratio of the hydrogen ion concentration. So for 1.6, this is the formula, right? Negative log of pH. Throw the negative to the other side, log of H, and then do 10 to the power of. So 10 to the power of negative 1.6 equals H plus. This is the hydrogen ion concentration of the first one. What's going to be the hydrogen ion concentration of 2.5? It's the same idea. The only difference is 1.6 becomes 2.5. So it's going to be 10 to the power of negative 2.5, like that, okay? 10 to the power of negative 1.5. So we have 10 to the power of negative 1.6 divided by 10 to the power of negative 2.5, and you get like 7.94 times. So this thing is almost 8 times as stronger as this. Even though it's not a big difference, it's only a 0.9 difference on the pH scale, but in terms of its strength, it's almost 8 times as big. That makes sense? Yeah, periodic table. You'll be using this a lot if you take grade 11, 12 chemistry. This next question has to do with intensity of earthquakes. Same idea, very, very similar. So what is it asking us? How much stronger is an earthquake of 4.5 on the Richter scale compared to 8? Which one is stronger in terms of earthquake intensity? 4.5 Richter scale or 8?
8.
8. So this one's flipped. Last time 1 was more stronger, right? The lower the number, the more stronger. This one's the other way around. So how much stronger it is? So 10 to the power of 8. Look at this is the formula here for intensity. For 8 Richter scale, the intensity is 10 to the power of 8. For 4.5 Richter scale, the intensity is 10 to the power of 4.5. So this becomes 10 to the power of 3.5. It's going to be a huge number. It's like over 3,000 times stronger. Even though the difference is only 3.5 between the two measures, it's 3,000 times stronger. That makes sense? How do you think an earthquake occurs? What's the idea? It has something to do with, these are called tectonic plates. There's like the crust, right? Here's like little trees and here's a big cities, whatever. Lies on the crust. The crust lies on the tectonic plates. Earthquake occurs when due to the movement of these tectonic plates, due to an abrupt movement,
Why did they move?
because they're kind of aligned like this. You see over here, there's friction, right? And eventually this friction breaks. Think of a rubber band, right? Like if you stretch it out long enough, it's gonna break. Same idea here. If you have one rock against another one, you're pushing it down. Let's say the other guy is pushing it up. That friction will eventually break, and that's what causes an earthquake. That's one of the reasons why. Another one would be volcanoes would do it. There's a bunch of reasons, but this is the main one, when there's an abrupt movement of the tectonic plates. Canada isn't too bad. Well, central Canada isn't too bad in terms of earthquakes. It's like probability is pretty low. But the western part over here and throughout the US, again, this is a very poor drawing, but the western part of Canada and the US, this right here is very prone to earthquakes. Because that's where one of the plates, the North American plate it's called, that's where it's in contact with, what's the name? I'm not going to pronounce this, but it's like the Spanish sounding name plate, which is like over here.
Mm-hmm.
And this area is very, very prone to earthquakes. And because it's Juan de Fuca, that's the name of the other plate. And because it's near the ocean, what happens when an earthquake occurs in the ocean? It leads to big waves, right? What are they called?
Tsunami.
Tsunamis, exactly. Same thing with Japan. Japan is like on the other side of the planet. Same thing is happening on this side of Japan in the Pacific Ocean. Very, very prone to tsunamis, these areas. I'm going to give you a really good, bad idea, basically. This one, we haven't figured it out, but the amount of energy released by an earthquake is astronomically high. So if we could somehow figure out a way to, collect that energy, right? We wouldn't need to be using fossil fuels. But it's easier said than done, right? How do you collect something like that? I don't know, maybe eventually we'll figure it out. Same thing with like any natural disasters, basic like hurricanes. The energy they emit is very, very high. So if we could ever figure out a way to capture it, then I don't think we'll be needing fossil fuels. Anyways, let's go to this question. So you have blue jeans, who doesn't? And you're washing it, and when you do wash it, it loses 2.2% of its color, or the dye. So let's say day one, it's dye concentration or whatever, it's very blue, 100%. But if you wash it once, right, it loses it by 2.2. So what is that? 97.8%. Now here's the difficult part. When it loses it a second time, is it going to become this number minus 2.2? Or is it going to become something else? So if you assuming this is a linear, then this would be the answer. If you're assuming it's exponential, the answer is going to be somewhere else. What do you think this is? Is it a linear or an exponential? We briefly talked about this yesterday. It's a very similar question. It loses 2.2% of the previous days, okay?
Mm-hmm.
Not the original. If it did of the original, it would be linear. But this one, it is going to be an exponential. It's going to lose 2.2 from here. So it's going to be something else. It's not going to be 95.6. And here's the formula for all of these. The letters are whatever. You can use whatever letters you want, but I'm just going to use NT. This is the final concentration of the dye. That is equals to N0, which is the initial concentration, which is going to be 100%, times 1 minus because it's losing, to the power of, and this is your rate, and T is the number of washings. So here, how many washings are required to give a pair of jeans a well-worn look? Which means 30% of the original. In this equation, which variables do we know right now? We know N0, right? What's the initial concentration?
100.
100, right? So that 100% is a 1. And we know our rate, so it's just going to be 0.9780. 1 minus 0.022. Yeah. So that's 1 minus that to the power of t. What's our final concentration? The answer is right here.
30%.
30%. So that's 0.3. 1 times anything is a 1, so you can ignore that. And here we go. This is the equation. How do we solve this for t?
You do log.
Yeah, you do log. So log of this is equals to log of that. The t comes in the front. So t will be log of 0.30 divided by log of 0.9780. Log of 0.3 divided by log of 0.9780. And that is 54. And that's the answer. So after 54 washings, it's going to be 30%. So yeah, that's the answer. It's a lot of washings. Here's another question that has to do with loudness, which is just a form of sound intenseness. We did it with there's a lot of words here, but I will highlight the ones that are important. So decibels is a measurement of how loud something is, okay? The formula for this is right here. L is equals to 10 times log of I divided by I0. This L is the decibels. This I in the numerator is the intensity. And this I0 is just a constant. It's like a pi. The value of this, well, it's not pi, but the value is 10 to the power negative 12. It's a constant. It will always be exactly the same. What is the question asking us? How many times more intense is the sound of a rock concert? So this compared to the sound of a subway. This. So the difference in decibels is 30, right?
Mm-hmm.
But is it 30 times more intense? It's gonna be way higher, I think, because again, this is on a log scale. So let's figure out how many times more intense it actually is. So the way to do this is they've given you your two L values because they've given you 90 decibels and 120 decibels. You need to find your two I values, the intensity values, and then you take the ratio of them. Here, let's do it for the subway. So the L value for the subway is 90. Then you have 10 times log of I divided by I0. Remember, I0 is just a constant, just treat it as a number. How do you solve this equation for I? I is right here. First get rid of the 10, right? Divide both sides by 10. Now what? Do we take logs on both sides? So there's already a log. If there's already a log, you probably shouldn't be taking logs on both sides. Turn it into an exponential equation. Remember, there's an invisible base there.
10 to the power of 9.
Yeah. 10 to the power of 9 is going to be I divided by I0, yeah?
Mm-hmm.
And remember, I0 is a constant. That means I is going to be 10 to the power of 9 times I0. This is for subway. And then we're going to do the same thing for the rock concert. So what's a decibel of rock concert? 120 equals 10 times log of I over I0. How do you solve this for I?
You divide by 10.
Yeah, and you've seen the pattern here. It's gonna be I is equals to 10 to the power of 12 here, because it's
Mm-hmm.
times I0. And this is for the raw concert, right? Raw concert. And then finally, you take the ratio between them. Which one would be higher, do you think? Raw concert or the subway in terms of sound intensity?
The raw concert.
So that's gonna go in the numerator. So you have 10 to the 12 times I0, which is for the raw concert, divided by 10 to the 9 times I0. The I0s cancel out. Then you have 10 to the power 12 over 10 to the power 9, which is 10 to the power of 3, and that will be 1,000. Okay?
Mm-hmm.
So a raw concert is 1,000 times more intense in terms of loudness compared to the subway. That makes sense?
Mm-hmm.
So usually if you go to a rock concert, you want to wear earplugs, because after a while you will get permanent hearing damage. Not a lot of people do that, but that's highly recommended. All these questions we've basically done. Let's look at this one though. Here's another intensity, but this is intensity of light. Why do plants need light? Can they survive without light? It has something to do with the word P.
Photosynthesis.
Yeah, so they require light to do photosynthesis. So this is the intensity of a light aquatic plants go through or they absorb. Here's a quick case study. Let's say you have a lake or a river or a pond or whatever, it doesn't matter. You can have aquatic plants. Aquatic plants usually are submerged, okay? Sometimes they can penetrate the surface of the water, but they don't have to penetrate. Like they can grow just fine over here. Let's say you have algae on the top. Would you expect these plants to be big or small?
Small.
Right, because it's gonna block off the sun, right? The
Mm-hmm.
light. And this is gonna actually have a cascading effect because now you blocked this off, and let's say you have some water species like fish that eat these things. Now they have run out of food supply, right? So that means these guys are also gonna be gone. It has multiple effects actually. And because there's so much algae now, the water of the pond is going to turn green. So that's why, how does algae form? Algae is a result of nutrition. It's limiting reagent, it's called. It's nutrition, and nutrition is gonna be phosphorus, the element phosphorus, and nitrogen. So let's say there is a factory here on the side, and it's throwing its waste, or the waste is actually seeping into this pond. The
Mm-hmm.
waste will contain nutrition, some form of nutrition that enables algae growth, and it's going to have a bunch of different effects. Anyways, going back to this question, this is our equation. The intensity is 10 to the power of 1 minus 0.3x, 0.13x. They require a light intensity of 4.2. Is I 4.2 or is X 4.2?
I.
So we have 4.2 is equals to 10, 1 minus 0.13x. How do you solve this equation for X? Remember, the unknown is in the exponent.
You do log.
You do log. So you have, and when you do log, that exponent is going to drop like this. What's log of 10? Remember, the way log works is like this. If you have log base 2 of 8, 2 to the power of something is 8. So the answer is going to be 3. If you have log of 100, the base is 10. 10 to the power of something is 100. The answer will be 2. Using the same concept, what's log of 10?
1.
1. 1 times anything is a 1, so you can ignore this. So that bracket is also gone. How do you solve this for x? It's a linear
You
equation.
add 1.
Adding 1 won't do it because if you think about it, you're going to get a 2 on the other side. It's not adding 1.
Subtracting.
Yeah, subtracting. So you get log of 4.2 minus 1 is equals to negative 0.13x. What's the next step?
Divide by 0.13.
Yeah,
Negative 0.13.
so log of 4.2 minus 1 divided by negative 0.13. The depth, what is it? X is the depth that we're looking for. It's going to be 2.9 meters. So anything that's deeper than 2.9 is not going to grow as much, okay? It'll grow, but just not as intense. We've done this question a few times now. This is just different wordings. The important thing is this number here, 2.1% of it is lost. And you have to top it up, or you have to refill the fluid when half of the original fluid remains. Those are the two keywords here. The equation for this, they're all very similar, but the equation for this is this. This is the final concentration. That's equals to the initial concentration. You're losing something, so it's going to be 1 minus R, and T is the cycle. Which one of these variables do we know here? What's the final concentration? When do we need to top it up?
When it's half.
So it's going to be 50%. What's the initial concentration?
100.
Yeah, so it's just going to be a 1. We know our R value, that's 0.021 to the power of T, like that. How do you solve this? Again, you're multiplying by a 1, it's kind of redundant. And 1 minus 0.021, I guess, is 0.979 to the power of T equals 0.50. What's next? How do you solve this for T?
You do log.
Yeah, you do log. So it'll be log of 0.979 to the T equals log of 0.50. The T is going to come in the front. So T is going to be log of 50 divided by that. Log of 0.5 divided by log of 0.979. The answer is 33 to the nearest whole number. So after 33 cycles, it would have to be filled up again. That makes sense? This next question is very similar. Don't know if we did this, but the formula, look at the formula. It just looks different, right? Last time we used this, This one, the money is going up, right? So instead of 1 minus r, it's going to be 1 plus r. Your initial sum is called the principal, which is going to be P, and your final amount is going to be A. So this is the final, this is the initial, just like before. T is the time in years, and R is the rate. What is the question asking us? Which one of these variables is the question asking us for?
A.
So it says how long will it take, right? How long will it take? So it's asking us for T. So our initial amount is 2,500.
Mm-hmm.
Our rate is 65, so 1 plus 0.065 is 1.065 to the power of T. What's our final amount?
4,000.
4,000. So there you go, that's our equation. How do you solve this for T?
You divide by 2,500.
You divide by 2,500, so 4,000 divided by 2,500 is 1.6. What's the next step?
And then you do log.
Then you do log, and you have it in the back. So it's going to be log of 1.6 divided by log of 1.065. So T is going to be 7.5. So after 7.5 years. And that's it. That's the question. Almost all equations are going to look like this. The only difference is for some doubling, like half-life or doubling or whatever, you're going to divide that by either the half-life or the doubling in the exponent. Everything else will look exactly the same.
Mm-hmm.
Try doing this. Don't know how this is relevant, but so there's a car that's traveling that has an interior sound level. This was the formula for sound, where L is the decibel amount, I is the intensity, and I0 is simply the constant.
Mm-hmm.
So the question is asking us, a second car has 2 times more intense sound. Calculate the sound level of the inside of the car. How would we approach this one? What are we actually looking for? So we're looking for the intensity, okay? That's what we're looking for. We're looking for the intensity of the second car. And if we have this, that'll give us the sound level of the second car, which is going to be the final answer, the decibel amount of the second car. To get this, you have to find the intensity of the second car. To get that intensity, you have to find the intensity of the first car and double it, because it says it's 2 times
Mm-hmm.
more intense. So here we need to first find the intensity of the first car. So we know the decibel amount is 70. 10 times log of I over I0. How do you solve this equation for I?
You divide by 10.
So get 7 equals log of I over I0. What's next? We're trying to solve for I.
You change it into 10 to the power of 7.
So 10 to the power of 7 is going to be I over I0, and then you can multiply both sides by I0. So this is the intensity of the first car. If the intensity of the second car is twice as much, what's the intensity of the second car?
What's I0?
I0 is just a constant. It's 10 to the power, if you want the number, it's 10 to the power of negative 14. So this is the intensity of the first car. The second car, it says it's twice as much.
You times it by 2.
You times it by 2. It's going to be 2 times I0, remember that's I0, times 10 to the power of 7. Now we are on this step right now. Intensity of the first car is this. Intensity of the second car is twice as much. Now finally, we need to plug this intensity back into the main equation up here to get the sound level. So now all you have to do is plug I, remember this is your I value, as this number, and that will give you the answer. So your sound level will be 10 times log of I value is 2 times I0 times 10 to the power 7 divided by I0, like that. Can we cancel out the I0s?
Yes.
Yes, so this and this is gone. And now you just plug this into a calculator. So 10 times log of 2 times 10 to the power of 7. So the answer is 73.01 decibels. And that will be the final answer. That make sense?
Mm-hmm.
So even though the sound intensity was twice in terms of the decibel amount, it only went up by 3. So keep that in mind. It's weird because if this is on a log scale, so in its purest form, it's not felt. It doesn't feel as high, but when you open it up, it's twice as much. So that's a big number. Try doing this one as well, why not? Inflation is 3.8% over the next 10 years. Write an equation to model the approximate cost, C, of goods and services. So this is very, very similar to the compound interest problem that we did. Inflation, is the price going to go up or down?
Up.
Up, right? So you're going to have 1 plus the rate somewhere in here. And let's say this is our initial amount. This is our final amount, C, and to the power of t, where t is time. So to answer part A, it's going to be C is going to be P, 1 plus R, so 1.038 to the power of t. That's the answer to part A. Part B, if the price of a brake job for a car is presently $400, estimate the price 10 years from now. So which values do we know for part B? Do we know the present value?
400.
400. Do we know how many years later they want the new price?
10.
So this is 10 and C, that's it. So 400 times 1.038 to the power of 10. So 10 years later, the price is gonna be $580. Part C, if the price of an oil change 10 years from now is 47.95, estimate the price today. So again, back to this equation, what do we know for part C? Do we know the future price C? We do, right? That's gonna be the number that
Mhm.
they've given us. So it's going to be 47.95 is going to be the future price. We're looking for the present price, P. The time is also 10 years, like that. How do you solve this equation for P? I'll give you a hint, it's linear. It's a linear equation right now because the unknown is already down on the same level. Which
You
means
divide by 1.03 to the power of 10.
that's it. That's all you have to do. So it's $33. So today it would be $33. 10 years later, it will be 47.95. Cool?
Mm-hmm.
So that's inflation. There are some fun questions down here somewhere. Let's start with this one. It says find the inverse. Remember, inverse, you flip it, okay? Here's how you do an inverse. I'm going to give you a quick review. To find the inverse of this, you gotta first interchange x and y. So x becomes y and y becomes x. That's the first step. And once you do this, you need to solve for the new y. So here, this is gonna become x equals 3y plus 9. Subtract 9 divided by 3. So this right here is the inverse of this original function. Okay?
Mm-hmm.
Let's use this idea to find the inverses of these guys. So again, x is going to become y is going to become x. Then we got to solve for this y up top. How do you solve for that y?
You do log.
You do log. So log of x is equals to log of 4 to the power of y. What's next?
You bring the y down.
And then you divide both sides by log of 4, okay, like that. And this one, if you have two logs, you can combine them. If you have a log of a divided by log of b, this becomes log b of a. So here I can rewrite this as log base 4 of x, okay, like that. There
Mm-hmm.
we go. That's the inverse. And if you want to write this in exponential form, 4 to the power of y is equals to x. That's the inverse. This is in the exponential form, and this is in the log form. Let's do the same thing for b. The first step is very simple. You just change x and y. How do you solve this equation for y?
It becomes 6 to the power of x.
Equals y, and there you go. That's the answer. That's the inverse of this. The question B is going to look something like this. Goes through the y-intercept, x-intercept of 1, whereas 6 to the power of y is simply a reflection on this diagonal line, which is y equals x, or 1x plus 0, if you wanted it in mx plus b form. It's going to look like this, and it goes through the y-intercept of 1. So this is this, and this one is this. That's what it looks like visually. This one says evaluate. So the final answer is just going to be a 1 number. It's just a simple number. Look at A. What do you think the answer is? So 3 to the power of something is 1 over 9.
3 to the power of -2.
Yeah, so the answer here will straight up is -2. This one, you're gonna have to combine it. Because you have log A minus log B.
You divide.
You divide, that's right. So you have log 5 of 100 over 4. What's 100 over 4?
25.
And what's the final answer then? Log base 5 of 25.
It's 2.
2 is correct, and that's gonna be the final answer, and you're done. Here's a half-life question. And the equation, I know it's a half-life question because it says right here. The equation of a half-life is this. The mass after t years is going to be the initial mass times the rate is going to be 1 minus 50% or just 50. 1 over 2 to the power of t is the time that has passed divided by h. Here, the important numbers are this, 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 and this, I guess, for part A anyways. So initially we had 100 grams. The half-life is 5730 years, 5,730. After 5,730 years, how much mass will be left is the question, part A. I'll tell you, you don't have to do any maths for this. The answer is simple. It has something to do with the definition of the half-life. So this is the half-life amount, right? 5,730. It would have exactly half of its mass. So if it started out with 100 grams, after
It would
it's
be
half,
50.
it'll be 50. That's it. Write an equation to represent the amount of carbon-14 that remains after t years. That's the equation, but we know our M0, our initial mass is 100, and we know that the half-life amount, the years it takes, is 5,730. Part C, after how many years would 80 grams of carbon be left? Now what are we looking for in part C? What is that 80? That's the final mass, yeah? That's M of t is 80. So we have 80, the final mass. That is equals to 100 times 1 over 2 to the power of t. It says after how many years? So our unknown is t divided by 5730, like that. How do we solve this for t?
You divide by the 100.
You divide by 100, so it's going to be 0.8 is equals to 1 over 2 to the power of t over 5730. And then the unknown is in the exponent, so you're going to use logs. So it'll look like log of 0.8, and you can bring that thing down, times log of 1 over 2. What's next? Now it's a linear equation. We're trying to solve for that t, right? So get rid of this, and you have the answer. T is going to be log of 0.8 divided by log of 1/2 times 5730. So 100 grams, it's going to take 5,730 years to become 50 grams. We're looking for 80 grams, so we're looking for some number in the middle here, less than 5,000. So log of 0.8 divided by log of 0.5 times 5730. The answer is 1,844 years. So this is the time it takes for this 100 grams to become 80 grams. And we are done with this question. And also done for the day. I'll see
Okay.
you next time.
Thank you.
Bye-bye.